Let's work on question 1 in this video. So we got a skiing championship and every skier needs to complete 2 runs. Now we have the data on 15 skiers. So we got 15 observations and they're in the table. We have for the first observation, the second, the differences, and we want to perform a sign test to see whether the tests on the first run are significantly higher than in the second run. And we got to write the hypothesis, conclusion, and so on. So first of all, what should ring a bell here? We have the same observations in 2 different settings. So we got 15 skiers in 2 different runs. So we got run 1 and run 2, which means that we have a relationship between them. So we have a matched pairs test, and the sign test is indeed a matched pairs test, but it's non-parametric. So we got a non-parametric matched pairs test. Now, what do we do in the sign test? We want to see whether the distributions are the same. So we're not actually interested in the differences of the means, but just whether the distributions are the same or not. And the intuition is that if they are the same, that there should be an even proportion of positive and negative differences between the 2 distributions. So the hypothesis under our sign test is whether the proportion of positive differences is 50% or not. And let's see in this alternative hypothesis, what are we testing? We are testing whether the times on the first run are significantly higher than the times on the second run. So what we are testing is that the differences between the first and the second are higher, meaning that the proportion should be more than 0.5. And why would we actually believe that? What's driving this hypothesis? Well, we look at the actual signs and we can see that we have 1 negative sign, 2 negative signs, 3 negative signs, but all the rest, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positive differences. So we can see that the trend is to have positive differences between the first and the second run. So we have a thought, we have a hypothesis that should be the case for the entire population, and we want to see whether that's true or not. Now, how do we perform a sign test? We use the binomial distribution, and the binomial distribution tells us whether this happened by chance or not. What is the probability of having so many positive differences by chance? So probability of having at least 12 positive differences by chance. Now, what matters in the binomial distribution? The number of observations and the proportions, because we have 3 columns in the table. Now let me zoom out to get some more space. So we're looking for the probability of having at least 12 positive differences, given that we have a sample size of 15 and a proportion under the null hypothesis of 0.5. And then we just take the data from the table. We take the probability of x being 12 plus the probability of x being 13 plus the probability of x being 14 plus the probability of x being 15. We cannot take any further than that because the sample size finishes at 15. And we just write the numbers. We write the probability that are already there. I'm gonna save the time by not writing them because it's just plugging them from the table. But if we add them up, we will get 0.017. Now, what does 0.017 mean? Well, that means that we have a 1.7%, just a 1.7% probability that this happened by chance, that these positive differences are by chance. These positive differences are by chance. Well, the probability of this being just by chance is really low, which means that it's most likely not by chance. It's because there is a significant difference between the distributions. So we have a significant difference between the distributions. That's what we're testing with the sign test. And the actual conclusion has to be in line with our alternative hypothesis, and we said that the proportion should be higher than 0.5, meaning that we have enough evidence that the times of the runs in the first distribution are higher than the second. So enough evidence that the run in the first distribution is greater than the run in the second distribution. Hope this makes sense. We are done.